in a liquid. Then what about the forces? Let's get into the forces. The liquid will exert. There's a flat face, no? There's a 3D diagram I'm showing. The plane diagram will just appear like this. Fine. There's a plane diagram, it will appear. So what are the forces? The forces everywhere will be no. And there's a one concept I'm trying to build with the help of this physical situation. Okay, there's a why the length of arrows? Because as you depth increases, the pressure will increase, the pressure force will increase. Similarly, look at these arrows also. Is it justified showing the arrows like this, with size? Look at the magnitude as well as okay, this is what happens. Now I say that hemisphere is in equilibrium, in a liquid. So the net force on it along X must be 0. The net force on it along Y-axis should be 0. Will I agree? This is very important. So what are the forces now? If you look at this, the net force on X-axis and Y-axis must be 0. So what force that acts on the flat face along X-axis, the same net force should act on the curved face. And it's a solid, it's having a weight. Then similarly what will happen? The liquid which is present below also will exert a force. The liquid which is up above also will exert a force. So therefore the resultant, the difference of these two is what? These two forces should balance the weight because it is being submerged, I'm saying. So this idea is what we are going to make, and we are going to bring a very simplified approach here. So what we should do now, I'll calculate the force acting on this particular circular strip. It will become like a circular strip. No, earlier we took rectangular, I took circular strip here. Then I'll calculate this force. What all you calculate force acting on this circular strip is equal to the force acting on this curved face because in equilibrium. And what are the difference in the force acting on upper layer and below layer? They should be equal to what? They should be equal to the density into volume immersion. Nothing but we can call that as a upward thrust. In books they have shown. I'll take another simple diagram. So let it be. Let it be submerged in a liquid. Similarly, what will happen? What force act on the flat face? The same horizontal force should also act on what? On the curved face. Will agree? So we have here flat face. If I say equilibrium, the net force along x-axis should be 0. How to calculate the force acting on the flat face? I think this will be a little bit easier. I brought a rectangular one. No? So what that is equal to? The pressure triangle idea. So we'll calculate pressure at this point. We'll calculate pressure at this point. Or we'll assume a strip at a depth y. So what is the df? Df equal to rho gy into select it 2r dy. the width will become 2r, no? This will become 2r. So like that, if I integrate this, so what should be the limit? Limit should be like I don't know this by naught. So this will become 2 rho GB. What all I'll get? 2 rho GR. Only 2 rho GR outside y dy. The limit will become y naught to y naught plus h. What is y naught? The depth at which the upper end is there. So 2 get cancelled. So rho GR y naught plus h whole square minus y naught square. There's a force. So shall I also say that there's a force acting on the flat face? So shall I say it is also equal to force acting on? See, we are developing an idea now. See, every time I can't say what's wrong in sir, I'll assume a strip. You can assume a strip, elemental strip, do it. It'll be very lengthy. Instead, this will be much easier, no? Pressure triangle idea. Still more. No need to write this also directly, but here the upper end is not exposed to atmosphere. So because of that open, we are going to take the limit. If this upper end is there at here, at the free surface, no, directly we would have wrote the pressure triangle formula. So we are just modifying it. So like this, we'll get the force acting on the flat surface or the flat face or on the curved face. Getting this, so there's a method what we can use to, like if a body is immersed, okay, different types of surface comes, no, we can take help of this particular approach. So this is going to help us a lot. What about the vertical force? Because like you didn't say anything about vertical. The liquid present here will exert a force. Another approach, let's develop. Like the liquid present here. So let me take this is F1 into A1, or the pressure at point 1. The pressure at here will be P2 into A2. Will I agree this? P1 A1, P2 A2. Where the pressure? Pressure will be more at 2, no? So then according to the formula, what is the pressure at 1? I'll minimize. So looking at the diagram, we'll see. What is the pressure at 1 at a depth? Neglect atmosphere. So this air is there. P naught 0. This everything is a liquid. What is P1? This approach is very important, which will help us to simplify the calculations in a simplest way. What is the pressure at 2? So P1 plus rho gh minus P2 equals 0. So P1 is what? Rho g y naught plus rho gh equal to P2. So which force will be greater? P2 A2 or P1 A1? Since A1 equal to A2. What is A1 equal to A2? Pi r square by 2. Got the idea? This one? Okay, let's come for the, which force will be greater? P2 will be greater, no? So therefore, what is the resultant force acting along y-axis? Fy should be equal to P2A2 minus P1A1. What is P2A2? Rho g h plus y naught minus rho g y naught. A1 equal to A2 is how much? Pi r square by 2. Finally, this will become only rho g h pi r square by 2. Tell me like h pi r square by 2 what it is? Volume immersed. What is Vi? Volume immersed of the body. So therefore, what is the net force exerted by the liquid on a solid object when it is fully immersed? Nothing but volume immersed into density of liquid into G. Don't write weight. Later, I'll come to that when I'm not bothered other things. So if I summarize, there's a basic idea of this one. So if you look at this total, this is a core idea which we are generating for our convenience, because what we are not interested in what, like we are not interested in the mathematics. We are not go for integration all the time. I'll just put a simplified diagram. Now we have like this, no? So the resultant, it is fully immersed in a liquid. No. So what is Fi? Fi will come like this. Fi will be non-zero. What about net resultant? Fx will be zero. Net force must be zero. I'm just showing on the either flat face or this one. What is Fi? Fi is very simple, no? So what you should do? Volume immersed into density of liquid. It is surrounded by that. So where do that Fi you have to show? You have to show here. So don't show Fx because net force is zero. What force is acting here? The similar force is acting here. Am I right? At least I think able to understand. So if any body is submerged, this is one idea. We are trying to take help of this method here. I'll adjust this diagram somewhere here. Again, why to go for one more page. Okay, fine. These are things. So you get very good challenging questions are there. So my approach is we should minimize mathematics. Worst case needed, you have to go for it. Otherwise, you should take help of this logical thinking. And this is what I think expected in advanced exams. Rather than blindly jumping into maths and solving, where you are unable to analyze, take help of mathematics. So therefore, what we can conclude here, the vertical force, I'll do conclusion. The vertical force exerted by liquid on submerged solid is equal to rho into Vi into G. So there's a thing. So what is Vi? Volume immersed of the solid. And rho is the density of liquid, not density of substance. So what is Vi? The net vertical, again, okay, fine. So this is one very good conclusion. So tomorrow, Otman, we do get again very good problems. I'll bring some other different cases. I just shown like a prior to, oh no, come for this. Like a solid hemisphere we have. Can we calculate what is the net force acting on the hemisphere along y-axis? Very easy, no? What is the volume of hemisphere? 2 by 3 pi r cube. Volume immersed, density of liquid we know, into G with the net force exerted by the liquid on the hemisphere which is submerged. What about, I want the force on the curved face. Somehow I can calculate force on the flat face. That is nothing but equal to same. So whenever a body is submerged, we are going to take help of this concept. Got the idea? Okay, tomorrow I'll continue exclusively on these things. So today I think maximum some ideas I give. So try to work out some problems from where all you have to work out.